Our next author, Elizabeth Kolbert, is the author of Field Notes from a Catastrophe, Man, Nature, and Climate Change in the Sixth Extinction, for which she won the Pulitzer Prize. For her work at The New Yorker, where she's a staff writer, she has received 2 National Magazine Awards and the Blake Dodd Prize from the American Academy of Arts and Letters. She lives in Williamstown, Massachusetts with her husband and children. In her latest book, Under a White Sky, she returns to humanity's transformative impact on the environment, now asking, after doing so much damage, can we change nature, and is there time to save it? Thank you so much for being here with us today, Elizabeth.
Thanks so much, Spencer, and thanks to everyone who's here today. And it's a tremendous honor to be here in such distinguished company. So I'm going to wrap things up today, I suppose you'll say, and talk to you a little bit about my latest book, Under White Sky. And Under White Sky was sort of inspired by a trip I took to Hawaii about 5 years ago to visit a project that had already been nicknamed the Super Coral Project. And heading up this project was a very dynamic marine biologist named Ruth Gates. And Ruth's idea was quite simple, but also it seemed to me quite extraordinary. So coral reefs, as you all probably know, are in trouble. They're in trouble for a lot of reasons, and probably the biggest of which is climate change. Reefs are found only in tropical waters, so they clearly need warm water. But they don't like it when the water gets too warm. When temperatures spike, you get this phenomenon known as coral bleaching, which is very damaging to reefs and can, in fact, kill them off entirely. And as the world warms, we are seeing more and more of these bleaching events, and we are seeing more and more reefs around the world are shrinking. So what Ruth noticed was that even on very badly damaged reefs, some corals usually survive. These corals are, for some reason, tougher than others. And her thought was that you could potentially cross these corals, crossbreed them, and get even tougher corals. And then you could use those corals to restock damaged reefs. This wouldn't be restoring the reef exactly. It would be creating a new kind of reef, a reef designed by humans to withstand human impacts. Our project is acknowledging that a future is coming where nature is no longer fully natural, Ruth told me at one point. I'm a realist, she said at another. I cannot continue to hope that our planet is not going to change radically. It already is changed. The Super Coral Project got me thinking about a future when nature is no longer fully natural. In a lot of ways, that future is already here. It's often said that we've entered a new epoch, the anthropocene, defined by human impacts on the planet. Global warming, industrial agriculture, plastic pollution, radioactive fallout, all of these human activities have altered the globe on a geological scale. The planet, as Ruth Gates observed, already is changed, and many people, along with countless other species, are already suffering as a result. The question is, what are we going to do now? I don't think it's an exaggeration to say that this is the defining question of our time. Of course, there's no simple answer to it. And this is why I wrote Under a White Sky. In the book, I try to present the information that students, really all citizens, need to consider. In this sense, Under a White Sky could not be more serious. But as a writer, I want to engage people. And so as serious as the subject matter is, the book is also darkly comic. In the end, I leave it to readers to decide how to respond. The book is not meant to settle the question, but to be unsettling. It's meant to spur discussions that challenge beliefs all across the political spectrum. And it was written very much with students in mind. They, after all, will be called upon to make the decisions that will decide the nature of the future. As you may know, I'm a reporter, and Under a White Sky is very much a reported book. Each chapter is built around a trip to some part of the world where people, usually scientists or engineers, but also sometimes ordinary citizens, are working to figure out how to intervene to counteract the effect of previous interventions. The book is not so much about the control of nature as about the control of nature. So in one chapter, I travel to Australia and meet with biologists who are gene editing cane toads. Cane toads are native to South America and Central America and the very southernmost tip of Texas. For amphibians, they are extremely large. Some are the size of dinner plates, and they will eat almost anything. In the late 19th century, someone got the idea that they could be used as what we would now call a biological control agent. The idea is that they would eat the insects that were feeding on sugarcane, which, as you know, is a very important cash crop in many parts of the world. So cane toads were imported to Puerto Rico for this purpose, and from there they were taken to Hawaii and eventually Australia. Now, cane toads probably never did much to help the sugarcane crop in any of these places. They weren't particularly interested in sugarcane beetles. But as I said, they will eat almost anything, so they found plenty of other things to consume. And in Australia in particular, their population exploded. There are now hundreds of millions, perhaps billions of them. And what distinguishes cane toads, besides the fact that they're so large, is that they're very poisonous. Australia has no native poison toads. In fact, it doesn't have any toads at all, any native toads. So its native fauna has not evolved any wariness of toads. So a lot of these animals eat cane toads and they wind up dead. And this has caused many of Australia's native species to crash. This includes several species of lizards, several species of snakes, and a very cute, but actually very ferocious marsupial called the northern quoll. So with gene editing, there's a possibility of producing a non-toxic cane toad. I visited scientists at this immensely secure facility who had in fact created non-toxic toads via gene editing. And this raises the question, should you release such gene-edited toads out into the world? Many people are deeply, viscerally opposed to this form of manipulation. But what if gene editing was the only way to save a species like the northern quoll from extinction? One of the scientists in Australia put it to me this way: what people are not seeing is that this is already a genetically modified environment. The entire cane toad genome, so some 20,000 genes, really shouldn't be in Australia. When you look at it in this way, altering 5 or 6 or 10 genes in the cane toad looks a whole lot less radical. Here in the US, we're facing a similar question with regard to the American chestnut tree. The American chestnut tree was pretty much wiped out in the first half of the 20th century by chestnut blight, which is a fungal disease that was probably brought to this country from Asia on Asian chestnut trees. Some 4 billion trees died, and with them, several species that depended on chestnuts. Scientists in Syracuse have now developed a genetically modified chestnut tree that can fend off chestnut blight. It has a single gene that was imported from wheat. This new tree, the super chestnut, we could call it, is now confined to a few fenced-in experimental plots. If the choice is between a genetically modified chestnut and no chestnut, what is the right call? That question is in front of US regulatory agencies right now, even as I speak. So in another chapter, I go to southern Louisiana, which is sinking into the Gulf of Mexico. One of the reasons it's sinking is we've figured out how to successfully control the Mississippi River. Back in the days before the river was leveed up, it overflowed its banks pretty much every spring. At that point, it was filled with sediment, which flooding dumped across the landscape, and this built up the soil. This is, in fact, how the entire Mississippi Delta was formed. But now, since the Mississippi doesn't flood any longer, there's no influx of new sediment. So the whole area is subsiding, and this includes the city of New Orleans. And so to try to save New Orleans, the state is now planning another series of massive public works projects. These are supposed to produce controlled flooding to counteract the effects of flood control. Finally, in the last chapter, I go to visit scientists working on what's known as solar geoengineering. This is the chapter that gives the book its title. The idea of solar geoengineering comes from volcanic eruptions, which, when they're big enough, shoot droplets of sulfur dioxide into the stratosphere. These reflective droplets bounce sunlight back towards space and produce temporary global cooling. If humans decided to mimic volcanoes by spreading some sort of reflective material in the stratosphere, we could potentially counteract some of the effects of global warming. A lot of people react to the notion of purposefully dimming the sun, so purposely reflecting sunlight back out to space, with horror. But what if it could reduce human suffering or prevent entire ecosystems like coral reefs from collapsing? We live in a world where deliberately dimming the bleeping sun might be less risky than not doing it, is how one of the scientists I interviewed put it to me. I think that students these days are rightly, deeply concerned about the state of the natural world. Under a White Sky, it doesn't provide easy answers, but it does offer new ways of looking at things. I believe it can engage students in thinking about complex questions that have no clear solutions. And for better or worse, those are the kinds of questions that they will be asked to grapple with. Thanks very much.